Hi, everyone. Thanks again for joining us today. I'm Chris with the First Events team, and I'll be helping with host responsibilities on the webinar today. Before we get started, I would like to remind everyone that speaker Q&A will take place in our conference Work Adventure platform. If you are just joining the stream and are not pre-registered, please send an email to events@first.org to get set up on the system. Work Adventure is hosting all of our conference networking activities as well as the conference exhibit hall. And with that, let's go ahead and get started, and I'll pass the mic over to our session moderator, Margareta Ram.
Thank you. Hi, everybody. So I'm Margot, and I'll be moderating this session today. I strongly recommend to join the Q&A and the social spaces in Work Adventure. That was a lot of fun yesterday. And now I'd like to introduce Kunihiko Yoshimura. He is a cybersecurity researcher from Fujitsu System Integration Laboratories, and he has many years of experience as a security analyst and researcher. He spoke at the first conference in 2018 about multi-dimensional malware similarities, S4, and in this talk, how to apply machine learning the appropriate way for our security operation. He will present the best practice on how machine learning should be applied using this sample similarity scoring system improvements as an example, and apply those methods in your environment to improve operations. So this should be very interesting. So go ahead. Thank you.
Yeah. Thank you, Margaret. Hi there. I'm Kunihiko Yoshimura from Fujitsu System Integration Laboratories. I'm happy to be speaking at this conference. Today, I will be giving a talk titled How to Apply Machine Learning, Appropriate Way for Security Operation. This page is about me. I have been working in the security field for 10 years. I have been doing security operations for 4 years and security research for 6 years. So I have a good understanding of both the operations and the research cultures. As a result of my research, I gave a talk at the first 13th annual conference 3 years ago. I'll talk about it later. Based on my experience in security operation and the knowledge from Research Institute, I would like to introduce a recommended method that also can be easily used in your field. Okay, number one is an introduction. In the security operation field, Security Operations Center (SOC) has the missions for defending organization. One of them is to monitor alerts and events and to alert the incident for IR team or customers. Another one is manage security appliances like firewalls. SOC is the front line in the security defense and like a star player in managed security services. SOC also has important tasks to complete these missions. One of them is to maintain signature rules of sensors or SIEMs. Purposes are to ignore false positive, remove old vulnerability rules that didn't exist in the field, and add signature rules that are appropriate for operations. SOC team is always busy with monitoring and managing. However, they should spend more time for maintaining the rules. Otherwise, an analyst cannot respond alerts effectively. As a result, he will not be able to keep up with it. This diagram is a structure of a system in my presentation at 3 years ago. I developed sample similarity scoring system S4, which determine most similar non-malware PCs for new malware. This tool divides the 17 similarity tools into 3 categories: surface, dynamic, and geometric. Integrates the similarity score using score transformation in each category, and output result in a ranking format. I talked about the effectiveness of multidimensional evaluation by integrating malware similarity tools scores. S4 succeeded clustering pieces of malware as malware families effectively and support malware analysts by reducing analysis time. The S4 is a useful tool, but had the difficult to tune problem. It is necessary to spend a time for maintain tuning parameter that used in the score transformation. When I integrated 17 tools scores for 3 dimensions, I set parameter of piecewise linear transformation, PLT, for all of tools. PLT is flexible for a human thinking, but it is complex. It needs much time for setting the appropriate parameter. In short, this tool gave an analyst time reduction, but also time increase. That is a fatal problem. In this chapter, I'll talk my approach that I try to apply machine learning for maintaining automatically tuning parameters. In each step, I will talk about basic stance for applying machine learning and examples I experienced in S4 case. First step, also most important step, we should pick a set of goods for machine learning. In other words, it is a planning for machine learning. At first, we decide type of machine learning. In general, there are 3 types that be known well: supervised learning, unsupervised learning, and reinforced learning. There are 3 important points. First, it's to define a cost function for machine learning. Of course, the status that cannot be judged by human being is neither by a machine. Secondly, what is the data you can prepare in the learning? You must prepare the data you refer in the operation, and to discriminate the types of the data. That is explained next slide. Okay, thirdly, ease of explanation. Recently, advanced algorithms like deep learning is coming in the world. However, in the security operation, I don't recommend that techniques is too advanced to control by a human, because it often occurs critical responsibility in our operation. So you should choose simpler algorithm like regression analysis. There are 2 main categories of data: Quantitative is the data that changes in a gradient, such as days or event counts. Qualitative is digital, such as on and off, or 1 and 0. It is important to be aware of which category the data to be trained will be. In the S4 case, scores from several tools can be prepared to create an integrated score. These are quantitative data. Yes. However, without PLT, we should not prepare integrated scores for learning in advance. We need to change our thinking. What could I use to prepare the data for learning? The answer is the two pieces of malware that scores that same family or different. This is qualitative data because there are only two poles, same and different. In the supervised learning, we choose predicting in a single variable from multiple variables in called multivariable analysis. Select the appropriate algorithm by applying it to the type of the data we have just organized. Yes, this is a case of S4. I chose to use logistic regression. I identify the tools that score high only for the same family, and then find the coefficient that minimize the distance between them and the logistic function. I mean, I changed score transformation logic from PLT to logistic function. The logistic regression feature is that the data that was qualitative at training will be between 1 and 0 in the prediction phase. That is quantitative data. This algorithm is highly recommended because of its versatility. This is because in the field of security operation, situations sometimes occur such as the past data is clearly malicious and benign. However, in the prediction stage, we want to predict the priority metric for responding first. Okay, step 3, let's code it. I chose to use Python because of its versatility, but I think you can use any language that suits your environment. The code in Python is very simple to put together. Just do a fit and predict. 2 lines of coding and you are done. Congratulations. However, merely implementing machine learning is not the goal. Rather, this is just a starting point. I will explain the actual hurdles I encountered when applying it and how I jumped over them. Okay, chapter 3 is trial and errors, these hurdles. Hurdle number 1 is a low winning rate. First, I used data from a test I did 3 years ago to see if I could successfully group them. As a result, one malaria family did not recognize many samples correctly. We will look at the output data to find the codes. The red text on the screen shows that the coefficient of 1/2 is a negative number. This means that the higher the score, the more different the family. We examine the correlation value between the target variable and the explanatory variables of the tool. Correlation value is an indicator of how much these two variables are related. The correlation value is 0.49, a positive number, which means that as one increases, the other also tends to increase. Why is this? When we look at other explanatory variables, we found that there was a very strong correlation with another explanatory variable. This problem is called multicollinearity, and it is one of the problems that must be avoided in various machine learning. There are several countermeasures. A simple solution is to disable one of the correct data, correlated data, but in this case, it could be extreme data. So we try to solve this problem by dimensional compression. In PCA, principal component analysis, a theory of efficient dimensional remake, there is a metric called the explanation ratio. When you try to represent the three truths in 3 dimensions and put those dimensions together efficiently in PCA, we are able to represent 97% of the original data in the 2-dimensional stage. We thought that if we could truncate the remaining percentage and perform regression analysis to restore the original dimensions, we would be able to obtain results that were not affected by multicollinearity. Okay, hurdle number 2. In further testing, I increased the number of families to be trained to 10. This seems to work fine, but when I ran the calculation with these parameters, I only got 42 points even if I got a perfect score with all the tools. Assuming that there are 2 samples in each of the 10 families. The number of combinations with different families is 4,500, and the same families is 450. If the data you want to train is extremely skewed, the results will have to be skewed to that side. This is called imbalanced data. The solution is simple. Adjust the amount of correct data. Increasing the amount of correct data is called oversampling, and decreasing the amount of incorrect data is called undersampling. Python already has a variety of logic modules like scikit-learn available for this purpose. You can choose the appropriate logic based on the nature of your data and sometimes by benchmarking each of them. Next hurdle. On the left side of the screen is the ranking result of the one of the three TrickBot samples. Normally, we would like to see TrickBot at the top of the list. But there are many different types of malware in the mix. In case like this, we examine the scores of each tool on the sample. Visualization is useful for examining the characteristic of data. If we examine the distribution of scores output by one of the tools on the right side of the screen, we can see that scores for different combinations have a single mountain, certain at 40%, and the scores for the same combination have two mountains, one certain at 80% and the other at 20%. If we focus on this 80% mountain, we can do machine learning that clearly captures the features. But machine learning evaluates both mountains equally and judges them as featureless. This problem is not general have a general name. I called this problem data overlap. As a countermeasure, processing is performed. Define something like what data should be ignored. And in this case, ignore the same combination of data that is less than the average of different combination of data. This way, each of them will become one mountain, and the tool will identify them as featureful. Now we'll verify that, that the machine learning system we've worked so hard to create work properly. First step is to select target malware families and retrieve sample randomly. We identified the malware families that were popular at the time from the monthly reports prepared by the Center for Internet Security, CIS. Obtained malware hash value from the information provided by the CTI vendor and downloaded the samples from VirusTotal. Next, compare samples between different months, arrange them in chronological order, learn from the past malware, and predict from the future malware. Finally, evaluation outputs verify that clustering is working by the correct rate and node graph. To determine the target malware families, I referred to the monthly reports published by CGIS. I chose malware families that had appeared in the rankings at least 5 times in the 7-month report at that time. We randomly selected from a hash list based on the CTI of 7 selected malware families and downloaded the samples present in VirusTotal. This page shows the correct rate from each malware, which is a quantitative evaluation result. For reference, the correct rate of a commercial malware similarity service is also shown. This service has not only the similarity between samples, but also the master data of malware families and benign software like Microsoft binaries. So the value of the service cannot be measured by just this. The S4 total correct rate is 76%. Which means that the accuracy of S4 similarity is compatible to that of commercial services. This is a qualitative evaluation with a node graph showing a relationship of 19 points or more. S4 connected samples of the same family successfully in the most of cases. Overall, we can say that the S4 tuning automation was a success. Okay, chapter 5, conclusion. S4, which I have just introduced, has a POC ready to be provided. We are discussing the possibility of making it open source carefully because of the risk of it falling into the hands of malware developers. If you are interested in S4, I can make it available to you via GitHub after signing an NDA. Please contact it. Okay, conclusion. My takeaway message is the procedures in this talk should help you improve your security operation with machine learning. In the SOC operation, analysts need to spend a long time for tasks like maintaining signature rules. Otherwise, you must respond to alerts, including many unnecessary ones. I solved S4 issues in the same way as mentioned above with machine learning. Okay, thank you for listening.
Right. Thank you very much. That was very interesting. And to all of you attending, I'd like to remind you that there will be a Q&A immediately following this presentation in Work Adventure. So there's a separate room where you can enter with your avatar and join, and I hope to see many of you there. Thank you so much for the presentation again.
Yeah, thank you, everyone.
Right. Right. We are ready for the next session. I would like to welcome you back here. I'm Margot, and I'll moderate this session. There will be a Q&A immediately following this presentation in Work Adventure, the virtual social platform where you also find the exhibitors and social activities. And it's my pleasure to introduce Simon Kennan. He is an independent security researcher and well-known in the security community. He has a broad experience in vulnerability analysis, malware analysis, forensics analysis, and developing detection logic, as well as keeping track of the exploit market and the world of web exploitation. Today, we will learn about what a carrier-grade NAT is, what the risks and dangers are of being part of such a NAT, especially during a pandemic. So over to you, Simon.
Thank you. Just let me share my screen first. Moment. It's kind of hard with multiple screens. Okay, so hello everyone. I hope you are doing well during those uncertain times. Thank you for joining me today for my talk about CGN, carrier-grade NAT, carrier-grade problems. This is my main agenda for the talk. I will start with some introduction about some basic concepts of the internet. Then I will explain what is CGN. Later, I will tell you why it is bad and what we can do to minimize the problems, or even fix them. This is the agenda for the introduction. This is not a very technical talk, but I do cover many topics in order to get to my point. So I hope you will keep up and learn some new things today. As mentioned, my name is Simon. I'm 34 years old. I do malware and NPT research for Clear Sky Cybersecurity in Israel. And this presentation has nothing to do with this kind of work. I've been hacking and passionate about information security since the age of 13. I had a PV6 on my Windows XP with 426 tunnel in 2007. And I allegedly did some interesting things over the years. In this talk, we are going way back to the 80s, when IPv4 became a standard. We slowly progressed until today to see what happened and where we went wrong. The internet was built on the end-to-end principle, which is simple. Data between two devices should be sent as is, without any manipulation on the way. Otherwise, our connection is not private, and we can't rely on the data to be secure and authentic. This is a diagram of how end-to-end should look like. According to the principle, the network is only responsible for providing the terminals with connections. Any kind of intelligence should be located at the terminals. An example for such intelligence is modifying a packet header, like destination or source. Back in the 80s, computers were big and expensive and not a common commodity like today. Even at a later point, each house didn't have more than one computer. This computer wasn't necessarily connected to the internet. And if it was, it wasn't 24/7. At some point, people had more than one computer at the house, but they had only one telephone or cable line. There was a need to connect multiple computers to the same external line. In order to do so, NAT was created. It maps multiple addresses to a single point by modifying the headers of the packets. This behavior breaks the end-to-end principle because it applies intelligence. But we control the NAT device, so it should be okay as long as we control it. In this diagram, we can see a home computer, which is part of a local network, trying to communicate with a server on the public internet. The NAT changes the addresses accordingly, so the router could route the packets back and forth to the right destination inside the local network. At some point, the internet became so popular, there was a fear it will be overpopulated by subscribers. This is because each subscriber should have a unique IPv4 address, and the IPv4 pool size wasn't big enough. In the days of the dial-up modems, those did the funky noises when dialing, ISPs started to give dynamic IPs to subscribers. This allowed ISPs to have more subscribers than IPs, because not everyone were connected at the same time. But if there was no free IP address, you simply could dial in and use the internet until someone would disconnect or the ISP would purchase more IP addresses. The depletion was anticipated since the 80s. Today, there are gray markets to buy or lease IPv4 addresses because all IPv4 space has been allocated and issued already. Let's go back to our timeline. In '94, NAT was proposed, and we all use NAT nowadays, one way or another. Only 2 years later, in '96, IPv6 was proposed in order to overcome the issues with IPv4 and to eliminate the need for NAT, so we could restore the end-to-end principle of the internet. Unfortunately, we are now in 2021, and we didn't fully adopt IPv6 yet. Instead, CGN was created, and it is widely adopted today. CGN is basically a large-scale NAT that the ISP controls. Each IP in this LAN belongs to a subscriber, which also might have their own controlled NAT. CGN was created because at some point, people not only had personal computers they had to connect to the internet, they had mobile phones with data plans. Those phones would dial in when internet was needed. But later on, we started to have smartphones that are 24/7 connected. All those devices need IP addresses, which mobile carriers couldn't provide. If you didn't know, 95% of mobile traffic in the world is behind CGN. If you have a smartphone, congratulations, you most likely use CGN. In this diagram of CGN, we can see the subscribers have full control over the private IP space until it leaves their home equipment and goes to the private IP space of the ISP. We don't control the carrier, not at all. Therefore, this might be risky. We can compare ISP to a bank. All customers hope the bank will keep their money safe. There are rules and regulations for that in most of the countries, but this is not the case with CGN. So what do? There are no IPv4 addresses left, and CGN doesn't seem like a good solution. If you've forgotten already, in '96, IPv6 was proposed. In '98, it became a draft standard. It was meant to fix all this nonsense. IPv6 can provide a unique external IPv6 address to all your internet-connected devices and restore the end-to-end principle of the internet. 4 years ago, in 2017, IPv6 finally became a standard, official standard, by the Internet Engineering Task Force. If IPv6 is so great, you would expect it to be widely adopted after 4 years. Unfortunately, we are in 2021. We have now internet-connected cars, yet IPv6 adaptation is still low. According to Google, only a third of Google users have IPv6. A site named whyknowipv6.com shows that less than half of Alexa top 1000 sites support IPv6, and that less than a third of Alexa top 1 million sites support IPv6. I will quote the site author and will say that this is a huge shame. I would like to personally ask you at the end of this presentation to check whether your home network supports IPv6 and if it is actually enabled. CGN adaptation, on the other hand, is only growing and will continue to grow if we won't switch to IPv6. Except the obvious fact that it breaks the end-to-end principle, there are different other issues in different aspects that CGN introduced. I will elaborate on those new issues in the next slides. Now you can see how CGN deployment should look like in theory. It is meant to be deployed in dual stack. Each subscriber has a CGN IPv4 address and also a public external IPv6 address, enjoying both legacy support for IPv4 and IPv6. Sounds good, but in reality, CGNs are the Wild West. Since we don't have control over the ISP NAT device, we don't know how it is configured. They can do whatever they want without regulation. Apparently, some ISPs give only NAT IPv4 address without any option for IPv6. The logical solution would be the opposite. I haven't heard of IPv6 only ISP yet, but there are some IPv6 only hosting services. There are many posts on the internet of people complaining they have issues with running some services. Most of these people either find out for the first time they are behind the CGN, and people tell them to enable IPv6 to solve all their problems. Small portion already knows that they are behind CGN. They also mention that the ISP doesn't have IPv6 support and ask for advice how to overcome this issue. But I have found this one particular interesting post. 1 year ago, a user on Reddit asked how CGN deployment impacts the users. As we saw earlier, it does. This user claims he works in ISP, and they are currently planning to deploy CGN without IPv6. This shows that although the CGN RFC clearly mentioned the deployment should be dual stack mode with transition mechanisms to IPv6, this is not necessarily how it is done in practice. On the other hand, my ISP does support dual stack, but you need to explicitly ask for it. They will tell you they don't officially support it, and the connection with the IPv6 enabled, for some reason, is not optimal, and you get better results with IPv6 disabled. Unfortunately, some people think that NAT is a security technique. You expose only the ports you need in the LAN addresses you want. No. NAT is not a firewall. This is only a byproduct from the workaround for the brokenness of the end-to-end principle that NAT introduced. If you run legacy OS inside the NAT, IPv6 can open a Pandora box if you don't configure your gateway firewall correctly. One patient zero can infect a whole ISP with a worm. You might see worms returning big time inside CGN networks. Because NAT breaks the end-to-end principle, some applications stop working. Different techniques are introduced in order to overcome these issues. UPnP is one of those. Akamai has published a research in 2018 about a campaign that exposes SMB ports on machines behind the NAT to exploit the eternal blue vulnerability. A subscriber inside the CGN can do the same, except it won't expose the ports to the public internet. He will expose them to the CGN private IPv4 address space. These kind of attacks are also called hole punching attacks. CGN deployments might be vulnerable to similar attacks, and with double punching those ports, it might be possible to expose these machines to the public internet eventually. As I mentioned, CGN was supposed to be deployed with dual stack to enable smooth transition to IPv6. In practice, CGN is deployed without any regulation, and sometimes without IPv6. Instead of adopting the real solution, we give live support to IPv4, although it was doomed a long time ago. On top of that, we add new internet-connected devices every day: IoT, smartwatches, even cars. Some of these new devices most likely don't even support IPv6. Ask yourself, do you really want your car to be connected to IPv4 CGN? If you are not sure about your answer to my previous question, take a look at this. The Europol already identified legal problems with CGN in 2017. Before CGN, everything was simple. If a security agency would give an IP address and a date to the ISP, the ISP would provide records of the subscriber and their internet activity. With CGN, multiple subscribers share the same IP. Does the ISP keep records of what's happening inside the CGN if there is no regulation? The quick answer is no. Here are some examples the Europol gave for cases being closed because of missing records for CGN activity. In one case, with partial records, 49 innocent people were questioned. The privacy was violated because of one criminal that shared the same IP address with them on the CGN. What would happen if the CGN IP was shared by 1,000 subscribers? Would 999 people will be questioned without doing anything? If you think about it, cybercriminal doesn't need a VPN. He just needs a CGN to cover his tracks. If he can combine both, he can be bulletproof. As we saw in the previous slide, your privacy can be violated indirectly because of the actions of a subscriber sharing the same external IP address with other innocent subscribers. But your privacy can also be violated directly by another subscriber. Because all the subscribers are inside the huge LAN, what stops someone from doing a port scan and perform reconnaissance on other subscribers? In some cases, it is even possible to determine the approximate geolocation of another subscriber. As mentioned much earlier, the end-to-end principle is broken. The CGN is a black box controlled by the SP. But what do they do actually with our packets? And finally, for the conspiracy lovers, here's one for you. What if the NSA had backdoors in the CGN equipment to spy on people? Think about it. The following text is taken from a research that was done in 2016. It says there is insufficient guidelines and regulations on CGN deployments and call it a black art, which leaves the subscriber with no other choice rather than to believe that his ISP knows how to do it. Now we approach the juicy part, security issues. Some CGN equipment ships with default passwords. Does the companies that sell these devices do proper security checks for these devices? As mentioned, other subscribers can actively or passively hack us because we are on the same LAN, actively by port scanning and exposing some vulnerability, or passively by a worm. Black hat hackers would want to get their foothold inside the CGN. Those networks must contain easy targets. Some network might be even full of specific vulnerable devices that are given by the ISP to all of the subscribers. Massive jackpot. Services that use IP address as additional security measure can be easily bypassed. If a hacker managed to get credentials to such service, and the credentials belong to a CGN resident, the hacker simply needs to be connected to the same CGN as the resident and easily bypass this additional security check, because both will have the same external IP address. In theory, to cause a DDoS to a CGN from outside of CGN should be easy. With some effort, it might be possible from inside as well. We simply need to overload the NAT table with open sessions. My ISP resets the subscriber connection each day at midnight. probably to flush all the open sessions. The DDoS impact in both scenarios is DDoS for all the CGN subscribers, as they can't initiate new connections because the NAT table is full. From blue team perspective, blocking a CGN IP will lead to a massive user block because of the actions of a single offender. I mentioned default passwords on CGN devices. I didn't make this up. This is an A10 device exposed to the public internet with default password. This is only the load balancer, but this might happen with CGN equipment as well. This device is running like that for over a year. This might be still a huge problem, as an issue with the load balancer most likely will affect the subscribers as well. Okay, now let's see some real-life examples of what actually happens inside the CGN. We can see the same subscriber receives a different CGN IP address and is connected to different gateways. This happens each time he reconnects. Once again, the legal issue comes to mind. Does the ASP log everything, or is it just random assignment? The same thing happens with IPv6. A dynamic IP allocation is made. Once more, the issue of logging user activity is being questioned. Most likely, IPv6 logging is insufficient at the ISP level and needs to be regulated. As I mentioned, a subscriber can scan the CGN subscribers, but he also can scan the CGN equipment to potentially hack it. There is no network isolation. This is a potential that only a CGN resident have, as those devices are not accessible directly from the public IPv4 space. You might think how bad this can be. Obviously, there would be devices with default passwords and security vulnerabilities, but this can happen on public IPv4 as well. However, CGN exposes some old risks, probably because someone thought that NAT is a security technique. We can find externally open file shares. It is like we're back to the early days of this millennium, when computers were connected directly without NAT, with the file shares exposed. Today, if a hacker will find such share, he will most likely leverage into some sort of ransomware attack. Now we can see an interesting case. I will call it a voodoo. We see a printer that has an internal LAN IP, an external IPv6 address as well, but it is also somehow exposed to the private IPv4 space of the CGN, although this IP is not listed anywhere on this page. This is most likely due to some sort of misconfiguration, but you can find similar cases in CGN networks in high numbers. At this point, I hope you understand that CGN can be problematic, but the solution is actually very simple. Upgrade to IPv6, restore end-to-end principle. Upgrade to IPv6, solve IPv4 exhaustion. Upgrade to IPv6, solve crime attribution. Upgrade to IPv6, restore full control over your network. Upgrade to IPv6, experience the full power of the internet. Upgrade to IPv6, it's 2021, it's time to upgrade. And yes, I wrote upgrade to IPv6 6 times on purpose. Okay, we have learned that we all use CGN in one way or another. Unfortunately, some of those CGN deployments are broken. CGN is basically the insider threat for residential networks. Due to COVID-19, many people work from home. Some of you might have a CGN at home. As I showed earlier, there are security issues with CGN. This should be considered as an additional risk factor to working from home. So there is no real benefit from CGN to a subscriber, maybe to the ISP. But remember, CGN is not a permanent solution. It was intended to be a transitional technology until we fully switch to IPv6. So let's embrace IPv6. Thank you for your time, and you're welcome to ask questions in Work Adventure or find me on Twitter. Hope you enjoyed my talk. Thank you.
Wow, thank you. It was very interesting to hear about the Wild West of CGN and, for instance, how criminals may just hide in the crowd. Again, I'd really like to thank you, although you paint a bleak picture. To all of you listening, there will be, I'd like to remind you about the Q&A immediately following this presentation in Work Adventure. And we also have some extra time now because we have a 15-minute break until a quarter after, so I guess 20 minutes. I'd like to invite you all to join us in session 1 for the featured panel, Life in Security, Practitioners in the Wild, with Nazira Kailash, Jeffrey Carpenter, Katie Masuris, and Caroline Wong. So, see you all there. Thank you.